Jim, we copied both solar
Welcome
wind and
to the atomic
penetrometer drum
classes.
in the ETB. Jim, we copied both solar wind and penetrometer drum in the ETB.
Not quite yet. I haven't put the solar wind in yet, but I will shortly. I want to watch this. Joe, you have a good picture there. I've got
Beautiful picture, Dave.
well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Which proves that Mr. Galileo was correct in his findings.
Superb.
So, before getting that question, that why NASA's vacuum laboratory gets failed in that experiment, in freefall experiment, first we have to understand the real meaning of freefall. Basically, freefall is the falling of a body on which only force of gravitation of the earth acts, known as freely falling body, and such fall of a body is known as free fall. What does it mean? If a body is falling only and only under the action of gravity and there is no net external force and there is no external force beside this gravitational force, there should be no air resistance. Okay, so such motions are called, or such falls are called free falls. Okay, so basically there is a very common misconception about the free fall, that some people say that a free fall is not possible, that free fall is not possible on earth, but it's a completely wrong statement. Basically, free fall could be possible everywhere. The only condition is that there should be no air resistance or not any other external force beside the gravitational force. Okay. On our earth, almost zero resistance is possible in NASA's laboratory, where they check the spacecraft by developing space conditions like temperature and pressure. As we know that in outer space there is no pressure, there is no air. Okay, so the pressure in the outer space is almost zero. So basically what they do in NASA's laboratory, they drop their laboratory pressure up to the minimum possible pressure that could be possible on the earth, and then they check the spacecrafts, that whether this spacecraft can survive in the outer space conditions or not. Okay, so this is all about the free fall. So here's our real problem. Here what the problem says, that the mass of an object A is 100 kg and object B is 1 kg. Both are taken to the same height and drop them freely under the effect of gravity. Do both reach the ground at the same time, or will the heavier one come first? Think and compare the gravitational force and momentum of both weights. You can ignore all the resistive forces in this question. All the resistive forces means you can ignore the air resistance as well. Okay, so as we know that the gravitational force is directly proportional to the mass of the object, and even momentum is also directly proportional to the mass of the object. So more the mass of the object, more the gravitational force. Okay, more the mass of the object, more the gravitational force, more the mass of the object, more the momentum. So as we know that m1 is greater than m2, because m1 is 100 kg and m2 is just 1 kg. So if m1 is greater than m2, then Fg1 means the gravitational force on the first object due to the earth is greater as compared to the second object. Similarly, the momentum on the first object is greater as compared to the second object. But the rate of change of velocity in both of the object is same. So both will race together with the same velocity, or we can say that acceleration due to the gravity on both objects is same, and which is 9.8 meter per second square. Yes, it is acceleration due to the gravity. It is acceleration due to the gravity. So the rate of change of velocity in both of the object is same. What does it mean? That both will come with the same speed. both will come with the same speed. The speed of both of these objects is going to change with the same rate. So both will fall with the same speed. If both are taking to the same height and both are dropping at the same time, both will reach to the with the same speed. Okay, so that is why if we take the heavier object and the lighter object to some height edge, and then both will reach together on the earth at the same time due to the acceleration due to the gravity. Okay, because the rate of change of velocity in both of the objects is same. So let's move to the next problem. So now suppose if someone asked me about the justification, that how you can justify your answer. So what you will do, suppose there is an astronaut and there is a spacecraft, or you can say spaceship. Okay, so if there is a spacecraft and there is an astronaut, both have some weight. Spacecraft weight is compared to the astronaut is more. So basically what happens, as we know that weight is the only force acting on the object. In outer space there is no air resistance, there are no resistive forces. So weight is the only force that is acting on the object, and that force is F is equal to W is equals to mg, isn't it? And if F is equal to mg, can I write that F is equal to ma as well? Because as we know that from the Newton's second law, F is equal to ma. So what we will do, we will extract the A, we will get A is equal to F upon m, and then we will write F upon m is equals to W upon m. So as we know that W is nothing but the weight of the object, and the weight of the object was mg. And you will see that the m and n mass of the object gets cancelled out, and the acceleration due to the gravity, you will get A equal to g, where g is equal to 9.8 meter per second square. Okay, so here we can say that mass does not affect motion, shape does not affect motion. Why? Because Galileo said that all objects fall at the same rate in a vacuum. This was the Galileo's statement, that all objects fall at the same rate in a vacuum. So this is all about the freely falling object. So now I hope that you understood the real problem. Why the NASA's vacuum chamber experiment? Why the NASA's vacuum chamber experiment gets failed? It means there was some air resistance. Okay, basically this is the NASA's power facility and world's biggest vacuum chamber. This is the place where scientists examine the spacecraft by developing or producing the outer space conditions. Like there is no pressure, there is no air resistance outside there. So in this chamber, they drop the pressure by removing the tons of air. Okay, so after creating vacuum in this chamber, only 2 gram of air, is left. So to bear such a large pressure, such a huge pressure, the walls of the chamber is made up of concrete and steel. But why we are doing this? Because as we know that for free fall there is only one condition, that there should be no air resistance, and if there is no air resistance, only in that condition the heavier and the lighter object both will reach to the ground at the same time if both are dropped from the same height. So let's remove the air.
It takes 3 hours to pump out the 800,000 cubic feet of air from the chamber.
Okay, we dropped 2 millitorr in the last 30 minutes.
But once it's complete, there's a near perfect vacuum inside.
7, 6, 5, 4. Cameras on. 2, 1. Release. Release.
Exactly.
Look at that.
They came down exactly the same. Wow. Look. Watch right there. Look at how they hit right there.
Exactly.
You're back on the side.
Exactly the same.
Feathers don't move, nothing.
Look at that. That's just brilliant.
Release.
Isaac Newton would say that the ball and the feather fall because there is a force pulling them down. Gravity. Yes, this is all about the Newtonian mechanics, which says that if you are taking two different objects at the same height, if you drop both of these objects at the same time, they will fall together or they will reach to the ground at the same time if there is no air resistance.